Hello. Okay, so today what we're going to talk about is characteristics of polynomial functions. Now, if you can turn to page 17 in your packet, we're going to follow along here. Okay, so the first thing we're going to talk about is the leading coefficient. Okay, your leading coefficient is just the number in front of your function. Okay, so as long as your function is written in standard form, where you have your biggest exponent first, and then it works its way down to the smallest exponent, the leading coefficient would be the number in front. So if you look at these three examples, right, the number in front here would be positive 1, this would be positive 1, and this would be positive 5. So if you notice, they're all positives. Whereas when we look at this example, we have a negative 1, a negative 1, and a negative 5. So these would all be negative leading coefficients. Now, if your leading coefficient is a positive number, all right, let's put a little star next to this point. Your right side points up. So if you look at these two graphs, right, do you agree this is the right side of the graph here? And this is the right side of the graph here? What's happening is our right side is going up to infinity. Okay, that's what happens when we have a positive leading coefficient. Whereas when you have a negative leading coefficient, look at the right side of this graph. And look at the right side of this graph. We don't care about the left side, just the right. Okay, look. When you have a negative leading coefficient, the right side points down. So let's put a star next to this. Okay, the right side points down. So I'm going to go to the right arrow of my graph and look at this. It's facing down. Same thing over here. It's facing down. So let's say I gave you, I'm going to draw a graph right here. I'm just going to make one up. You can put this on your paper if you want. Okay, there's my x and y axis. Let's say my graph looks like this. Okay, does this graph have a positive or a negative leading coefficient? All right, if you said positive leading coefficient, you're right, because look, we're looking at the right side of the graph and it's pointing up. So if it's pointing up, it means it has a positive leading coefficient, right? Whereas if it looked like this, let me draw my axes in the same color. If it looked like, let's just say this, that would be a negative leading coefficient, right? Because the right side is pointing down. Okay, so that's how we tell by looking at a graph whether the leading coefficient is positive or negative. Okay, now let's talk about the degree of the function. Okay, so the degree, we know the degree is the biggest exponent. Okay, so let's put this in our notes, right? Degree, we could tell the degree by looking at the highest exponent, the biggest exponent. So, for example, if we look at, if we look at these three examples right here, here we have the biggest exponent is a 4, so it's a 4th degree function. Here our biggest exponent is a 2, so that would be a 2nd degree function. And same thing here, the biggest exponent is a 2, that would be a 2nd degree function. Here, all of these are even numbers. When your degree, when you have an even degree function, what happens is, let's put a star next to this, okay? Both ends point in the same direction. So, this is what I mean. If you look at these arrows on your graph, okay, the left side of the graph and the right side of the graph, aren't they both pointing up? Okay, they're both pointing in the same direction. Or look at this one. See these arrows, the one on the left and the one on the right, they're both pointing down. They're both pointing in the same direction. So, why don't we write this on our graph? Up, up, down, down. If they both point in the same direction, then we can tell that the biggest exponent of our function is going to be an even number. Okay, whereas, look over here. These are all odd degree functions, right? The biggest exponent is a 3. Even though we don't see it, isn't there technically a 1 right here and a 5? Okay, these are all odd numbers. So if we have an odd degree function, let's put a star next to this, the ends point in the, actually that's wrong. Let's cross that off. The ends point in, cross this off right here. I must have done a copy and paste direction. Opposite directions. Okay, I'm hoping to fix that on your packet before I photocopy it. So hopefully your paper, you won't even have to fix this. So let me cross this off. It should say 1 up and 1 down. So hopefully that's already fixed on your paper, but if not, please fix that for me. Okay, so if we look over here, let's start with this graph. See how the left side points down and the right side points up? Okay, so we have down, up. Okay, they're pointing in opposite directions. Okay, same thing here, except the left side's pointing up and the right side's pointing down. But either way, they're pointing in opposite directions. So if they're pointing in opposite directions, the degree of your function is going to be an odd number. Okay, one more thing we're going to talk about before we try any examples is end behavior. End behavior just means what is your function doing as you look at either end of the graph. Now, when we read this, I know you've probably never seen this symbol. It means approaches. So we say as x approaches negative infinity. Okay, so let's think about what that means. As x approaches negative infinity. So here's our x-axis, right? If we want to go towards negative infinity, aren't we going this way? Which way is that? To the left or to the right? That's to the left. So whenever we see this is another way of saying, as we look to the left, so I'm going to put left in parentheses. Okay. Now f of x, isn't that just a fancy way of saying y? We want to know, what are the y values approaching? Are they getting very big and approaching infinity, right? Are they going up? Or are they getting very small and approaching negative infinity? Okay, so we'll worry about that when we get to some examples. But I also want to talk about what this means. Because for right now, this is the way we're going to start every single end behavior problem we write. Now this says, as x approaches positive infinity. So let's think about x. Here's our x-axis. If we want to go to positive infinity, aren't we going to the right? Okay, so whenever we see this, we're talking about what's happening as we go to the right on our graph. So let's put right in parentheses. So as we go to the right on our graph, f of x approaches. So what are the y values doing? Are they getting big? Are they getting small? So let's take a look at some examples and see what happens. Okay, so let's look at the ones. We have 4 examples right here. All right, I'm going to make this a little bigger as we write. So let me just make this a little bigger. Okay, and we'll start with this one in the top left box. Now, if you look at this graph, right, I'm actually going to write, remember, up and up. That could help us. Okay, so now, this is written out for us as x approaches negative infinity. Okay, so if you recall, as x approaches negative infinity, doesn't that mean we're going to the left? So as we go to the left, I'm just going to put that in parentheses to remind us. F of x approaches what? So let's look at the left on our graph, right? Isn't this the left side of our graph? So as we look at our graph on the left, isn't the graph going up? If we're going up, aren't the y values or the f of x values approaching positive infinity? Okay, so we can put a positive infinity here. Now this says as x approaches positive infinity, right? As the x values get bigger and bigger and bigger. Didn't we say that means we're going to the right on our graph? So as we go to the right on our graph, f of x approaches, well, in this graph, let's look at the right arrow. As we're going to the right, isn't it also going up? So if it's going up, that means we're also approaching positive infinity. So for end behavior, you have 2 mathematical sentences. Okay, here's our first one. This is what happens as we go to the left on our graph. And here's the second one. This is what happens as we go to the right on our graph. Okay, now I'm no longer going to write left and right. But let's keep that in mind. We know this means as we go to the left, what is happening to our y values. Now let's first write, okay, this time we're pointing down, and this time we're pointing up. So as we go to the left, look at that left arrow, it's pointing down. So if it's pointing down, isn't the y values approaching negative infinity? And here, as x approaches positive infinity, as we go to the right, let's look at the right on our graph. Isn't that graph pointing up? If it's pointing up, doesn't that mean the y values are getting bigger and bigger, so they're approaching positive infinity? Okay, hit pause and try the 2 on the bottom on your own. Okay, let's see how you did. So if we look at this one, look, this is pointing down, this is pointing down. So as we go to the left on our graph, here's the left side, it's pointing down. So that means the y values are approaching negative infinity. As we look to the right on our graph, here's the right. Look, that's also pointing down. So the y values will also be approaching negative infinity. Okay, now one more. Over here on the left, right, as x approaches negative infinity on the left, the graph is pointing up. If it's pointing up, this will be positive infinity. And see how this is pointing down? If this is pointing down, right, on the right, we're going to be approaching negative infinity. And that's it. So when you write out end behavior, well, for right now, at this point in math, you are going to start off your sentences the same way. You're always going to write this out. And really, the only thing that changes is what you're putting here and here. Okay, so if you flip to the next page, we're going to end off with some examples on this page. Now, if you look at the directions, it says for each of the following, you want to determine whether it represents an odd degree or an even degree polynomial. Then we have to determine the sign of the leading coefficient, and then we want to describe the end behavior. Okay, so let's start with number 25. Now, before we answer any of these, I like to write up or down. So we could see on the left side of our graph, this is pointing down. And on the right side of our graph, right, this is up. And I know they didn't use arrows, but if you go to the edge, the very, very end of a graph, you actually don't need to put arrows. It implies it's continuing on. If you want to put arrows, you can. That's up to you. Okay, now, this graph is a cubic, right? A cubic polynomial function. Now, let's just think about this. If we want to determine whether it's an odd degree or an even degree, do you remember if they're opening in different directions? If one is up and one is down, look back in your notes if you have to. But that's an odd degree function. Now, please don't just write odd, because we're going to learn about odd and even functions. Those are different. This is called an odd degree function. So the degree of the function is going to be an odd number. Okay, letter B. Determine the sign of the leading coefficient. Now, remember, we only look at the right side of the graph. If it's pointing up, it has a positive leading coefficient. If it's pointing down, it has a negative. So this one's pointing up. So this is going to have a positive leading coefficient. Now, as far as end behavior goes, remember, we start off writing the same thing. And don't try to shortcut this. If you try to, shortcut this, you will not get credit. You want to say, as x approaches negative infinity. Now, I'm just going to write f of x. Sometimes you may have a g of x, you may have an h of x. You could even write y, because they don't say really anything about a function. But I'm going to write f of x approaches, and I'm going to fill that in a minute. We also know our second mathematical sentence here is going to say, as x approaches positive infinity, f of x approaches, and we're going to fill that in. Okay, so let's think about it. As we look to the left, our graph is pointing down. So this is going to approach negative infinity. Oop, I'm kind of running out of room on my paper. That says infinity. Okay, now here, this means as we go to the right. So as we go to the right, look at that, our graph is pointing up. So that means we're going to be approaching positive infinity. Okay, I'd like you to hit pause real quick, try out 26 on your own, and then you can hit play and see how you did. Okay, so for part A, if one says up and one says down, if they're in different directions, then what that means is we again have an odd degree function. And again, please don't just write odd, it's the degree that's odd degree. Okay, so for part B, we only are concerned with what's happening on the right side of our graph to determine whether the leading coefficient is positive or negative. So here, it's pointing down, so that means we have a negative leading coefficient. Okay, and then for part C, they want us to describe the end behavior, so we have to write out both of those complete mathematical sentences. Okay, so we start off by writing the same thing every time for right now, right, for the problems we're doing now. As x approaches negative infinity, as we go to the left on our graph, well, if it's pointing up, the y values, f of x, is going to approach positive infinity. Whereas, as x approaches positive infinity, as we look to the right, the y values, well, on the right, this is pointing down, so the y values are approaching negative infinity. And one more thing I want to point out, right? If we know this is a cubic by looking at it, cubic would be x to the third power, right? We know right off the bat that's an odd degree. Whereas look at the next one, that is a quadratic, y equals x squared. So that should just be an even degree.